Hey there, folks. I don't know if you've been paying much attention to the news lately, but if you have, you might have seen an interesting story, which is that in the last couple of days, SpaceX has launched people from the Florida Space Coast to this place right here, the International Space Station. In order to do that, this Crew Dragon capsule that they launched, and it has to match the velocity of this space station, which I can tell you is 7,660 meters per second. That's this number right here. So that's the velocity that this thing's traveling around the Earth. We're going to use compound unit conversions to answer what is essentially a pretty simple question, right? And that is, how fast is this really? And at first glance, that might seem like a silly question to ask, because how fast is it? Well, meters per second, that's it's a unit of velocity. So how fast this is exactly this fast, 7660 meters per second. The problem is that's not in a unit or on a scale that makes a lot of sense to our brains. Why is that? It's because for those of us not fortunate enough to commute to work via Falcon 9 rocket, we are stuck down here commuting to work in this, pedestrian, or a little faster than pedestrian, I guess, speed range of 25 to 75 miles per hour. I bet those speeds, for those of us who drive, make a little bit of intuitive sense. We can picture what 25 miles per hour feels like. We can picture what 75 miles per hour looks like. Actually, my wife saw this. She said that should say 85 miles per hour. She's a little bit of a speed demon. I drive like my grandmother, frankly. So I'm going to stick to 75 miles per hour, but this is our range. This is what makes sense to us. And so the challenge for this compound unit conversion is first to put this unit, put this velocity expression into a unit that makes sense to our brains, and then we're going to see if that's on a scale that makes sense to our brains. To do that, we need to kind of accept three basic mathematical facts that I bet are not going to be shocking to anybody here. Let's take a look at them. The first is that if you make a ratio of two numbers that are equal to each other, then that ratio will be equal to 1. So mathematically, that's saying if A equals B, then when we make a ratio A over B, it's going to be equal to 1. And the same thing would be true for the inverse of this ratio, right? B over A would also be equal to 1. Okay, the second basic mathematical fact we need to make these compound unit conversions work is to remember that if you multiply any number by 1, that number doesn't get changed at all, right? So if we take A and we multiply by 1, we're still going to get A back out of this. And the third mathematical fact is really, in a way, just a restatement of the first mathematical fact. But that third mathematical fact says that when we have identical values that appear in both the numerator and the denominator of a ratio, those identical values can cancel each other out. We don't even have to calculate them. Let me show you what I mean by that. If I have a ratio that is the product of A times B divided by the product of B times C, well, B appears in both the numerator and the denominator. And that means that we can cancel those out. Just picture crossing a line through them. And the ratio is really just A divided by C. So if we can keep these three mathematical facts in our mind, we can convert any compound unit to any other compound unit that we care to. So here's our three basic math facts. We'll leave these here so that we can reference them as we go along. And let's just identify the challenge here. The challenge is that, well, this unit is not in miles and this part of the unit is not in hours. And miles per hour is how our brain works. So to make this compound unit conversion, it's going to start with an equivalence, two values that are equal to each other. And in this case, the two values that we're going to look at least to start with, to fix this half of the problem, not in miles, is that 1 mile is equal to 1,609 meters. If I have one equivalence like this, I can actually produce two, what we're going to call conversion factors. Conversion factors are ratios that are essentially equal to 1. Now, to be clear about this, I am not telling you that the value of 1 over 1609 is equal to 1. It's not. It's clearly If you plug this into a calculator and you get some number, I think, if I got this right, it's going to be something a little higher than 0.005. It's going to be a little higher than that. But we're not saying that 1 over 1609 is equal to 1. We're saying that 1 mile, right? The context matters, the unit matters, and we're saying that 1 mile is equal to 1609 meters. And because these two are functionally, contextually equivalent to each other, their ratio is mathematically equivalent to 1. We should point out that the other ratio is also true, right? 1609 meters divided by 1 mile, these are equal to each other. This will also equal 1. And so the trick that we need to see here is that one mathematical equivalence between two units can produce for us two different conversion factors, and those two different conversion factors will be useful in different scenarios. So we're going to start this math by looking at 7660 meters per 1 second, which is exactly what this unit tells us, right? We can imagine a 1 in the denominator here. So 7660 meters every 1 second is our velocity. And what we want to do is we want to multiply this velocity by a conversion factor that will do something to our units to get them more sensible. So I'm just randomly picking one. I'm going to pick this one right here, 1609 meters per mile. So here we are. We're going to take this, we're going to multiply by this. If we multiply this through, we are going to get this number right here, 12.3 million meters squared per second mile. And right away we can see the problem didn't get any simpler. Nothing happened for us here. We're just left with this really confusing unit, meters squared per second mile, that just isn't a thing, right? It doesn't simplify the problem. So this is our first indication that we went off course here somewhere, and the place we went off course was by picking the wrong conversion factor. We'll see what makes the conversion factor right when we redo this. So let's try this with the other conversion factor, right? Let's 1 mile over 1609 meters. If we multiply this through, we're going to get 7660 meter miles divided by 1609 second meters. But here's our third mathematical fact, right? Here's this one right here. It says that if identical values appear in the numerator and the denominator, we can cancel them out. Well, check this out. We've got meters in the numerator and we've got meters in the denominator, so we can scratch these guys out and we'll get 7660 miles in 1609 seconds. Sorry, is that right? Yep, that's right, 7660 miles in 1609 seconds. And if we simplify that fraction down to give us 1 second in the denominator, what we're getting is 4.76 miles per second. And already, because miles make more sense to our brain than meters do, we're getting a feel for how fast this is. And you're probably aware now that this is pretty darn fast, but it's still not intuitive. It's still not intuitive because miles per second is not a unit that we really work with ever for our day-to-day life. So let's keep going with this conversion. Let's take care of this second half of the problem, which is that the denominator is not in hours. So to do this, we're going to need some equivalences. We're going to need at least an equivalence. I don't know how many seconds are in an hour. I could probably figure it out if I tried. But what's intuitive to me is that 60 seconds are in a minute and 60 minutes are in 1 hour. So I have two equivalences that I can work with here. And of course, each one's going to produce two conversion factors. So I have 4 conversion factors at my disposal. I have 60 seconds per minute. I have 1 minute per 60 seconds. I have 60 minutes per hour. I have 1 hour per 60 minutes. All of these are useful, but in our scenario, we're going to select these carefully. We're going to select them carefully to make sure that we are canceling out the units that we don't want anymore. We're going to take values that appear in the denominator and make sure we're multiplying by a conversion factor that move those values, or those units rather, to the numerator, so that when we multiply these things through, we have a shot of canceling these out and getting a simpler unit. So we're going to, if we make this multiplication, we'll get miles per minute. Those seconds will cancel out, but miles per minute is not what we're after. We're actually after miles per hour. So we're going to choose another conversion factor that moves those minutes from the denominator up into the numerator. We can multiply this through to get 17,136 miles second minutes divided by 1 second minute hour. But of course, our seconds will cancel, our minutes will cancel, and we're getting a value of 17,136 miles per hour. So we've done the conversion now. We're in the right units. We're at miles per hour. Here's the problem with this. Here's why I think we need to go a step further. We need to go a step further because remember our range that made sense to us, right? 25 to 75 miles per hour. We're way outside of that range, right? We still can't intuitively interpret 17,136 miles per hour. So instead, I want to try to find some context that makes this number make sense to us. So I want you to imagine that you live in Farragut and it's the good old days when we all used to go to campus and actually get together and see each other face to face, right? And if you lived in Farragut and you were driving to campus, that's going to take you about 20 minutes. It's going to take you about 20 minutes to drive that 17.4 miles, at least if you trust Google. I used to do this drive and I think it took a little longer than 20 minutes, but you know what? We're going to trust Google today. Okay, so the way that I want to put this value, the 17,000 plus miles per hour, into context for us is to try and compare it, a relative measurement, compare it to something that makes sense to us, right? This 20-minute commute by car from Farragut to campus. And so the question I want to pose is, what would this commute look like? How long would this commute take if you could commute via the International Space Station? How would you do that? I have no idea. Maybe you throw a giant lasso up there and you just hold on really, really, really tight, right? Something like that. But the point is, how would our travel time compare if we were traveling at 17 plus thousand miles per hour, like the ISS, rather than the 25 to 75 miles per hour we travel by car? So it turns out this question, how long will it take to get to campus if we were commuting by ISS, this can be handled just like a unit conversion. Let me show you what I mean by that. We can work this problem like a unit conversion because our velocity, 17,136 miles per hour, is in fact a conversion factor of sorts, right? It's a very specific conversion factor, very specific to the scenario where you're traveling on the International Space Station. But if I told you, hey, I was on the ISS the other day, you know, no big whoop, but I was up there, and I traveled for 17,136 miles. You could say to me, wait, you mean you were up there for 1 hour? You're traveling for 1 hour? And I would have to say, yeah, that's absolutely correct, because those two values, 1 hour traveled on this International Space Station or 17,136 miles traveled on the International Space Station, they are equivalent to each other. This is an equivalence, which means that this velocity, very specific to this scenario, is a conversion factor, right? And of course, the other conversion factor works, and this is the one that we're going to need to work with for this problem. Why is that? It's because this expresses the velocity of the International Space Station in terms of time per unit distance, right? So time per distance. And when we ask this question, how long would it take to get to campus? We are asking a question about how much time would it take per some distance to travel. So we can work this problem like a unit conversion if all we want to do, or in order to do that, all we have to do is to find units that are meaningful to answer the question, right? And in this case, I'm going to tell you the units are going to be, you know, time per trip, right? What some unit of time, which we already have in hours, per unit of trip. So we can take an equivalence. We can say one trip, according to Google, was 17.4 miles. Now we can work this like a conversion problem. Here's our two conversion factors we get from that equivalence. We can talk about trips per mile per 17.4 miles, or we can talk about 17.4 miles per trip. And we are going to multiply this in a way, remember, that moves units we want to eliminate from the denominator into the numerator, or vice versa. So we want to think about this in terms of how much time per trip, and so we need to get these miles out of here. And so this is our conversion factor from our equivalence. Here's our equivalence, and here is the conversion factor we're going to use in order to get rid of these miles. Now we could multiply this through right now, but I think, you know, if we did this, we get 17.4 divided by 17,000. We're gonna have some really small fraction of an hour, and our brains don't work in fractions of hours. So let's try and make this make even more sense. Let's use some conversion factors we've already seen. Let's not talk about it in terms of hours. Let's talk about it in terms of minutes. But you know, my gut still tells me it's even still going to be some small fraction of a minute. And again, we don't work in fractions of minutes in our brain. We do seem to understand seconds pretty well. So let's make this compound unit conversion Just kind of to evaluate what we're doing here, we're taking the hours and we are putting them from the numerator down into the denominator. That's going to put us into units of minutes, but that wasn't good enough. So we're going to take the minutes, we're going to take them from the numerator, we're going to put them down into the denominator. And now we can just multiply straight through top and bottom. That's going to give us 62,640 hour, mile, minute, seconds divided by 17,136 mile, trip, hour, minutes. Okay, very confusing units. But we have our third mathematical fact that you can cancel things from the numerator and the denominator. That means these hours are going to go away, these miles are going to go away, these minutes are going to go away. And if we simplify this fraction, we'll be in units of seconds per trip. That's going to give us a meaningful answer. We can picture how many seconds it takes to make this trip to campus. All we have to do is simplify this fraction. And if we simplified this fraction, here's the answer. Here's the answer that we would get. We would see if we simplified the fraction that it would take 3.65 seconds per trip if we could commute from Farragut to campus via the velocity of the International Space Station. So let's finish up by answering the question that we set out to answer, right? 7660 meters per second, the velocity of the International Space Station. How fast is this really? So we've looked at it in terms of miles per hour, more than 17,000 miles per hour. We've looked at it in terms of time per trip between Farragut and campus, 3.6 something seconds to get to campus. So to put it in very, very technical scientific terms, how fast is 7660 meters per second? Really, in a way that makes sense to our brain, technically speaking, that's pretty darn fast.